Okay. Our maths lesson today, we are going to look at angle relationships, measurement, and geometry. Angle relationships, measurement, and geometry. And today we shall look at points, lines, interval, and angles. We shall look at points, lines, intervals, and angles. So the first one we shall look at is a point. A point is denoted by a capital letter and the dot. A letter can be any letter ranging from A to Z, but mine have used a P. So when you have a point denoted like this, we are looking at this as a point, which is usually denoted with capital letter. 2, we have line. A line is denoted with 2 points. In this particular case, I'm calling it A and B. And if we have A and B, we shall say that A and B is a line. So we call it line A, B, or we shall call it line B, A. So this is a line, either AB or BA. You realize that this line extends indefinitely, either direction. It can extend towards through B onwards or through A onwards. It extends indefinitely. We have the third that we call a plane. Now when we look at a plane, this is just a flat surface. And when you look at a flat surface, it could be the wall, it's a plane. It could be the top of a table, it's a plane. It could be the floor of a room, it's a plane. And you will find that a plane extends in either direction indefinitely. A plane extends either direction indefinitely. The third piece that we have is what we call collinear points. And for the collinear points, we have a line, and you can have, I'll take for example 3 points. This line is extending upwards, it's also extending downwards. So the point A, the point B, and the point C are 3 points, all of them lying on the same straight line. And we say that point A, B, and C are collinear. Therefore, we say that collinear points are points that lie on a single straight line. If 2 or more lines, let me take 2 for this case, meet at a particular point or intersect at a point, we say that these lines form an intersection. So you realize that the line here, AB, and then the line here, CD, intersect at a point. And that's the point we call the point of intersection. But if we have more than 2 lines intersecting, so I'll add another line, then let me call this line E, F. So these are more than 2 lines. When more than 2 lines intersect, then we say that they actually form points that we call concurrent. We say the lines are concurrent. So more than two lines that meet at the same point are concurrent. So the line AB, CD, and EF are said to be concurrent. We have lines that have endpoints. They don't extend. You will notice that we don't have an arrow at A, neither do we have an arrow at B. So it is an endpoint for B and an endpoint for A. So this line AB, because they have endpoints, we call them a segment. We call them a segment or an interval. So the space between A and B is either a segment or it's called an interval. So we can call the interval that we have, we can denote it using the letters. So we can say this is either segment AB or segment BA. Depending on either side you'll choose to call. If you don't want to call it segment, you'll say interval AB or interval BA. We have what we call array. And array is simply an arm. We have a point and we have an arrow in one end. And for array, if we had A, B, but it's moving in one direction of B endless, we call this array because it has one end running indefinitely. So this is what we actually call array, or alternatively, we can also call it an arm. When we have two rays meeting at a point, so let me bring another one here, so that now we have two of them. I call this point C. Now these are two rays. They are intersecting at a point. So when two rays or two lines meet at an angle, then we find that the point of intersection here forms an angle. When we have two lines or two rays meeting, they form an angle. Now the two rays here, that is AB and AC, are called arms. The two rays that we have are called arms of an angle. And you realize that the angle is at this particular point. So we can call this an angle, or alternatively, if the angle is unknown, then we shall say this angle which will be denoted by small letter. When the angle is not known, we shall say this is angle A, which is denoted when the angle is not known. When we have two lines, and the two lines are parallel, they are running endless on either sides. The lines we have here is a pair of lines, and the lines are parallel. We have line A, B, and we have line C, D. So these two lines are parallel, and for us to denote or show that two lines are parallel, we shall say that the lines A, B is parallel. This sign stands for parallel to CD. So we can say that the lines AB is parallel to CD. Or alternatively, the line BA is parallel to DC. So this is when you are showing that two lines are parallel. We have perpendicular lines, We have perpendicular lines, and to denote perpendicular lines, we need to understand what perpendicular lines are. These are lines which intersect at 90 degrees. When we have lines intersecting at 90 degrees, line AB and line CD meeting at 90 degrees, we say that the two lines are perpendicular. And you can simply denote that by saying the line AB is perpendicular to the line CD. This symbol here shows that the two lines are perpendicular to each other. That is what that particular line means. We also have a situation where the parallel lines form a figure, and this particular case, the figure we want to look at is called a parallelogram. This figure here, the two opposite sides are parallel. The two opposite angles are equal. So we have A, B, C, and D. So the figure that we have, A, B, C, and D, are parallelogram. And the opposite sides are parallel. It is shown by the signs here. The opposite side again are parallel. Now the sign that shows that the opposite angles are equal, we only have the sign shown. You'll notice that we have simply a single arc, which simply shows that the angle, this is the symbol for an angle, the angle DAB. This is an angle is equal to DCB. So the angle DAB, that is this angle here, is equal to DCB. DCB is that angle again. So on the same figure, we should also identify another pair of angles which is equal. You'll notice that from this figure, we have other angles, the angle ADC. ADC, that is this angle with double arc, is equals to ABC. So the angle ABC is equal to angle ADC, and it will be denoted by ADC is equals to angle ABC. So this is showing that we have got equal angles. Note that the opposite side, we say they are parallel, so it is always good to again show that the opposite sides were equal in this particular figure. So we shall go ahead and say at the same time, besides the angles being equal, also we notice that the lines AD is equal to the line BC. The line AD is equal to the line BC. And at the same time, the line AB, we have AB is here, is equal to the line DC. So that is simply showing us that a parallelogram has got two opposite sides equal and has got two opposite angles equal. So now that we've identified that an interval is simply given by two endpoints, A and B, I want us to come up now with an angle and identify how two lines forms an angle. So when I bring another line here, and let me call it C, you realize that we have AB as an interval or a segment, and AC as also an interval or a segment. At the point where they intersect, it forms an angle. So this angle, the smaller part here, the inside, forms an acute angle, we shall say, call it acute angle ABC. So this is an acute angle ABC. However, we can also have the same being shown, that this time round it's from the outside. So we are running the angle from here all the way back here. This one is a reflex angle. It is a reflex angle, and we shall call it angle. This point was A, so angle BAC. Angle BAC. For the acute angle BAC, it is the inside that reflects the angle. So this one is acute angle BAC. This is acute angle BAC. This is a reflex angle BAC. These angles are not the same. They are different. And that's why we must show that one is reflex and another one is an acute angle. As an exercise, draw a representation of the following. Draw a representation of the following. One, so we expect you to draw a representation of the following. One, draw a point P. Two, explain what it means. Explain what it means by the following. Explain what it means. A, the points, when you say the points are collinear, and B, three lines are concurrent. At the same time, looking at the room, you can also be able to identify a few mathematical applications. So I want us to look at the room inside here and identify which parts forms the following. Identify which parts forms the following. Interval, arm, plane. So identify in the room which parts of the room can form interval, arms, and a plane. So you will notice the following. A point, for us to illustrate a point, we shall simply show a point by a dot and a capital letter. So we have been able to show that we have a point. The second part, explain what it means. The points are collinear. When do we say that the points are collinear? First of all, when we have several points, 3 or more points, lying on the same straight line, that's when we say that these points are collinear. So to illustrate the collinear points, we need a line which is straight, and we have the points. I'm taking 3 points, the point A, the point B, and the point C. So we say that the point A, point B, and point C are on the same straight line, and therefore the 3 points are collinear. The next question was asking us, three lines are concurrent. When do we say that three lines are concurrent? To illustrate this, we shall need to have three lines, and all the three lines must intersect at one point. So I'll have the first line here. This line, let me call it line A, B. The next line I can have this. This line here, let me call it line C, D, and another line running that side. And this line here, I'll call it line E, F. So we have three lines, line A, B, line C, D, and line E, F. So three lines, all of them intersect at this central point. Therefore, we say that the three lines AB, CD, and EF are concurrent. So lines are concurrent when they intersect at the same point and there are more than two lines. Now, the third question, which was asking us to look at the room and identify inside the room which areas can give us interval, which areas can give us an arms, and which one can give us a plane. It's very simple. When we want to find two endpoints, let us take, for example, inside the room. You'll find that on top of the room is an endpoint. Is an endpoint where we have the ceiling. So we can't go beyond the ceiling. And at the bottom here, we have the floor. You can't go beyond the floor. So when we pick one edge from the ceiling down to the floor, there are endpoints. So you can say that it represents an interval. Then for the arms, two arms are supposed to give us an angle. So we shall look at a place where we have actually two intervals. So two areas where we have intervals intersecting or meeting to form an angle is what will give us an arm. So when you take one wall and a floor, it forms an edge. And then we take another wall again and a floor, it forms another edge. You realize that here, one wall will form a line, another one will form a line. Where they are meeting here, they'll have formed the angle. And we said that two arms form an angle. So you realize that one edge, that's the floor and the wall, is forming one arm and another one forming the other arm. Hence, where they meet, forming a known angle, and I'm calling it a degrees. The last part is a plane. When we talk about a plane is simply a surface. So anything you touch is a surface. So the board we are using here is a surface. It could be a small board, a big board, or even much more wider. As long as it's a surface, then it forms what you call a plane. So we can simply illustrate a plane. So this is a wall, be it our wall, the board, the floor. This is a wall. It can extend either direction. And when it does this, that is what we call a plane. So in the room, we are able to identify a plane right from the floor. It's a plane. The walls are plane. And if your house has a ceiling, it's also a plane. When you look at the room, also you have a table. The top of the table is also another plane. If you are using a screen, there are many areas you can use. If you are using a TV set, then a TV set, that face also represents a plane. When you look at smartphones, when you are using smartphones, the smartphones also, the face is also representing a plane. So we can be able to identify planes of various images or shapes in the house or even in other areas, because any surface that you touch is always taken to be a plane. In our next class, we are going to look at adjacent angles and vertically opposite angles. In our next class, we shall look at adjacent angles and vertically opposite angles. Thank you. Okay, in today's class, we are going to look at the topic measuring and classifying angles in mathematics. Measuring and classifying angles in mathematics. Earlier on, we saw that it is very easy to identify an angle, given that an angle is what is formed when we have two arms intersecting. So this time round, we want to classify these angles according to their sizes. Looking at the first one here, we have two arms intersecting, but they are forming a certain angle, and this angle is smaller or less than 90 degrees. This one we refer to it as an acute angle. Acute angle. Acute angle is an angle that falls between 0 degrees and 90 degrees. That is what we call an acute angle. The second type of angle is a right angled angle. This right angle is an angle that is 90 degrees. We can either write it as 90 degrees, or we give this sign which shows that it is a right angle. So this type of angle is called right angle, or is an angle which is equal to 90 degrees. So this is 90 degrees and it's called a right angle. The third category that we have of angles is the angle that falls between 90 degrees to 180 degrees. This is the third category, and this angle is above 90 but less than 180 degrees. It is called an obtuse. An obtuse angle. An angle that lies between 90 degrees but less than 180 degrees. We have the next, which others refer to it as a straight line. But for our case, when we consider an angle, we are looking at an angle which will have 180 degrees. An angle with 180 degrees is referred to as a straight line, so we just call it a straight. It's a straight line because it simply moves from 0 degrees up to 180 degrees. So if we have exactly 180 degrees, that one is a straight line. The next angle that we have is what we call a reflex angle. Reflex. A reflex angle is an angle that is above, that is between 180 degrees all the way to 360 degrees. So this one is seen to be a reflex angle because it is greater than 180 but less than 360. We refer to it as a reflex angle. We have what we call a complete revolution, which is an angle of 360 degrees. One complete rotation forms 360 degrees. That is what we refer to as a revolution. So when you talk of a revolution, we are talking about 360 degrees. So all the angles in mathematics falls between 0 degrees to 300 degrees, and they'll always be classified as either acute angle, which is between 0 and 90, a right angle, which is exactly 90 degrees, an obtuse angle, which is between 90 and 180 degrees, a straight line, which is exactly 180 degrees, a reflex, which is an angle between 180 and 360, and finally a revolution, which is one complete rotation, exactly 360 degrees. So when we look at angles, all these angles are measured using an equipment called a protractor. This is a protractor and is meant to measure the degrees. We have the scale ranging from 0 degrees, 10, 20, all the way up to 90, and it moves to 180. Most protractors have got two scales. One starting from the right, 0, all the way to the left side of 180 degrees, while the second scale starts from the left side, 0, 10, all the way to the other side of the right-hand side where we have 180 degrees. This is because an angle can be measured from any direction. So I'm going to take the first angle that we have here and see how to measure the angle. Because 0 begins from, for this particular case, our 0 is the first one, the line here. Along this line is where we have our 0, then we move to 10 and so on. We are going to use the inner scale, 10, 20, 30 and so on, and find out how many degrees is this. On our protractor, we have the central point here. We have the scale here reading 25 up to 50. This is just for a meter rule, but the center is where we have the 25. That is where the point should touch the vertex of the two arms that forms the angle that we have in this particular case. So we want to estimate the angle A and find out how many degrees is this particular angle. So we shall consider the horizontal line, the first arm, this one, and the line that we have up there. So you'll bring the center of the protractor to the vertex here. And then it should lie on the same line here. So you'll realize that when you measure, you'll find that this is 10, 20, 30, 40. It's approximately somewhere here. Our protractor is not labeled with the smaller units. It's with the interval of 5, 5, 5. But we can estimate it to about 42 degrees. So you can say A is 42 degrees. That is when we are using the inner scale. When do we use the scale on the other side? You'll find that we want to measure the angle that is on the other side. So let me using this second diagram here, I'll extend the line. I'll extend the line such that we want to measure this obtuse angle, but this time round we want to use the other scale so that it can give us exactly the angle between this part and that. We can alternatively measure straight using the inner scale, but I want us to use the other scale on the other side. Taking the center to the vertex here, if you are to use this side, this begins from 0 all the way. You realize that it is reaching, this is 100, this is 120 from the inside, 130, this is 135. 135 degrees. That's what you know the angle here, if I call it angle B, degrees is 135 degrees. But let us see, supposing we were using this other end, how could we arrive at the same 135 degrees? Similarly, we bring the center to where we have the vertex, and then we make sure that this horizontal of the protractor lies on the first arm, and we read it upward. So this one is 5, 10, we have 15, 20, 30, we have 40, 45. So it's reading 45. Take note, from the first end to the last end is 180 degrees. And we are finding that this is 45. So you'll find that to read this angle, we shall take 180 degrees less the angle we read on the left-hand side, which is 45 degrees. You'll find that our angles here, it will come to 135 degrees. So it's just the same, and it is an obtuse angle. So that is how we estimate the angles using a protractor. So a protractor is an equipment used to measure all the angles that we may come across, be it acute, obtuse, right angle, reflex, straight, or a complete revolution. So at this time, we want to identify and say what type of angles are the following images. State the type of the angle shown. So the first one, so we have the first one and the second one here. So state the type of angle shown between A and B. So for us to tell what type of angle is here, we need to look at the behavior of the degrees. Where we have the arc running from the outside is what we shall be measuring. Now, for the first one here, you realize that for us to measure it, we shall measure from the inside, and you'll find that it is resting approximately 46 degrees inside. But this is not what we want. It is 46 the inside, but the angle we want is the outside. So for us to get that, we shall take a complete revolution, which is 360 degrees minus what we've measured, 46 degrees. So when you subtract that, you realize that for us to get the obtuse angle, you'll find that is going to give us 314 degrees. 314 degrees. And therefore, because 314 degrees falls between 180 degrees all the way to 360 degrees, then it implies that this first figure, the angle we have is therefore a reflex angle. So for the first figure, the angle we have is a reflex angle. For the second one, it can be easily identified even without using the protractor, because the first thing we look at, we are looking at this, the angle inside. If it is greater than 90, then we are talking over an angle that is going to be formed between 90 and 180. This angle here, if you look at it, 90 is somewhere here. If we had a 90, it will be here. So you realize that the angle here is greater than 90, which implies that if it is greater than 90 and it's less than 180, then what type of an angle is that? Then the angle here, you'll find that it's an obtuse, and the reason being given is because it's an angle that is greater than 90 but less than 180. That is how we identify the angles at any given time. So we have what we call adjacent angles and vertically opposite angles. So angles that are adjacent and angles that are vertically opposite. Adjacent angles and angles that are vertically opposite. But in most cases here we are going to consider special angles, and these ones can be illustrated with the following diagram. Now this, estimating that the angle here between the arms here is 90 degrees, that is, this is a right angle, which means it's 90 degrees. So if we have an angle, so we have an angle dividing the two, angle A and angle B. Angle A and angle B. We find that adjacent angles are angles that they are sharing, that they are side by side, or they are sharing a vertex and they are next to the other one. They are sharing one arm in common. So A and B are adjacent angles. But at the same time, this angle, the two angles, add up to 90 degrees because we have estimated and we have a right angle sign here. The two angles add up to 90 degrees. Then we say that the pair of angles A and B are called complementary angles. Angle A and B are complementary because A plus B must give us 90 degrees. And that's why it's an adjacent angle that is formed between an angle that is right angled. That is why we say A and B are complementary, because they add up to 90 degrees. We have the second pair of angles, that this one we call supplementary angles. Supplementary angles. And to illustrate this, we have 180 degrees, which is normally a straight line from this point, and then any adjacent angle should give us that. We have A and B here. Now, in this particular case, these angles are not the same. This is a different angle and this one is a different angle. However, when you add A to B, you realize that we get a straight line. They form a straight line. Therefore, we say that angle A and angle B, when you add them together, they form 180 degrees. Therefore, the two angles form what are called supplementary angles. A and B is a pair of supplementary angles because they add up to 180 degrees. The last pair of angles that we have are those angles which, when we add them together, they give us a revolution. And note that a revolution is 360 degrees. So taking this angle here, so we have the first angle here, this is angle A, and then we have another angle here, this is angle B. So you start from here all the way, you finish angle B, angle A, and then you move again all the way to finish angle A. You'll have moved one complete revolution. And earlier on we saw that a complete revolution is equivalent to 360 degrees. So if we have angles that can add up to 360, then that pair of angles, we call them, these are angles that sum up to 360. This is a pair that forms a revolution. So we shall say that angle A and angle B is a pair of angles that forms a revolution. They form a revolution. So these are the special angles. We have all angles that add up to 90 degrees. We call them complementary angles. Those which add up to 180 degrees, we call them supplementary angles. And the angles that add up to 360 degrees, they form what we call a revolution. Those are the pairs of angles about the special angles. Now we have the other group of vertically opposite angles. Earlier on, we saw that when two lines intersect at a point, they form an intersection. Now, this is the case. We shall find that there are angles that are formed which are vertically opposite. And we normally say that these angles, or vertically opposite angles, are always said to be equal. So the type of angles, like we have angle A here, this is B, C, and D. So vertically opposite angles. Vertically opposite angles. We should be able to identify which angles are vertically opposite. For this case, A and B are vertically opposite. C and D are vertically opposite. So it implies that A and B are equal. Therefore, vertically opposite angles are always equal. Vertically opposite angles are always equal. So identify which other angles here are equal. You will notice that angle C is equal to angle D. Just the way we have seen angle A is equals to angle B. The reason being that these are angles that are formed by two lines intersecting. Therefore, they form angles that are vertically opposite each other, and those angles are equal. So for an exercise, so write the missing word. Write the missing word. And the diagram that we have A is A degrees here and B degrees there. So the question is, A and B are dash angles. A and B are dash angles. You'll notice that we need to first identify from the diagram what is A and B, what relationship connects them. You'll notice that A and B, when put together, they are going to form one straight line. And if they are going to form one straight line, then we ask ourselves, what do we call the angles that form one straight line, which is 180 degrees? Then you'll notice that A and B are supplementary angles. It's a pair of supplementary angles. We have other pairs we should be able to fill. Those ones for 90 degrees, complementary angles, and a complete revolution. In our next class, we are going to look at transversal lines and parallel lines. That is it for today. Thank you.